day 18 of 75, and today we break one of the biggest mental blocks in DSA. You see a sorted array, you reach for binary search, but what happens when there's no array at all? Binary search on answers is the technique that turns impossible to optimize problems into 30-iteration solutions. By the end of 5 minutes, you'll spot the hidden sorted structure in problems that don't look like search problems at all. Let's get into it. Quick warm-up. Classic binary search runs over array indices: low, high, mid, compare, shrink. The reason it works is monotonicity. Everything left of the target is smaller, everything right is bigger. That ordering is the whole trick. Now here's the inversion. What if the thing that's sorted isn't your data, but the space of possible answers? If you can ask, is this answer good enough? And that question flips from no to yes exactly once, you can binary search the answer itself. Take split array largest sum. You've got an array and a number k. Split it into k contiguous subarrays. Minimize the largest subarray sum. Your gut says dynamic programming, and DP works, but it's O, n times sum, painfully slow. Pause and ask the inverted question instead. Can I split this array into k parts where no part exceeds some value mid? That's a yes or no question. And critically, if mid works, then mid plus 1 also works. A bigger budget is never harder. That's your monotonic predicate hiding in plain sight. Let's build the predicate. A greedy lambda. Bool can't split. Walk the array once, keep a running sum, and every time adding the next number would exceed mid, you cut. Start a new subarray. Increment your piece count. If the number of pieces you needed is less than or equal to k, return true. That's 10, in, scan, no DP table. The beauty is this predicate is false, 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 then true, true, true as mid increases. We just need the very first true, and finding the first true in a monotone sequence is exactly what binary search does. Now wire it up. The bounds aren't arbitrary. Derive them from the problem. The smallest possible answer is max of nums. You can never beat your largest single element since it can't be split. The largest possible answer is the sum of nums, one giant subarray. So low equals the max element, high equals STD, accumulate of the whole thing. Use long for that sum. Integer overflow on high is the exact bug interviewers plant to filter candidates. Then the loop, while low less than high, mid is low plus high minus low over 2. If can't split at mid, high equals mid, else low equals mid plus 1. When they meet, low is your answer. Watch the boundary semantics, because this is where people lose the offer. When the predicate is true, we keep mid as a candidate. High equals mid, not mid minus 1, because mid might be the answer. When it's false, we discard it. Low equals mid plus 1. That asymmetry is what makes the loop converge on the first true. If you'd rather not handroll it, STD. Partition underscore point over accounting range does the same job with the same predicate lambda. Same idea, less boilerplate. Let's talk complexity, because this is the payoff. The search range spans up to 10 to the 9th. Log base 2 of that is about 30. 30 iterations, each running in O, N, predicate scan. So the whole thing is O, N log of max value, versus that O, N times sum, DP. We replaced a sum-sized factor with a log of some factor. That's the difference between a billion operations and a few thousand. One more knob. If your answer is a real number instead of an integer, swap the integer loop for a fixed iteration count. About 100 iterations of mid equals low plus high over 2 gets you well past double precision. Here's why this matters beyond one problem. It's a template, not a trick. Any optimization question with a feasibility check is secretly a binary search. Coco eating bananas? Binary search the eating speed. Predicate checks if she finishes in H hours. Aggressive cows? Binary search the minimum gap. Predicate greedily places cows after sorting. Capacity to ship packages? Binary search. The capacity. Same shell every time. Monotone predicate as the loop body. Binary search as the outer wrapper. Day 18 done. The takeaway: when no array exists, search the answer space. Write a monotone yes or no predicate, and let binary search find its first true. Tomorrow we push this further. Subscribe for day 19.